Here is the correct solution to 2B triple I. We need to look at the projection of our basis. So let our basis, not a basis, let our basis. Let our basis be E1, E2, and E3. That is 1, 0, 0, 0, 1, 0, and 0, 0, 1. We need to find the projection of these three vectors onto the plane P. Now, we have two vectors. We have U1 is 1, negative 1, 0, and we have U2 is equal to 1, 1, negative 2. And U1 dot U1 is going to be 1, negative 1, 0 dotted with itself. 1, negative 1, 0 dotted with itself. You multiply those numbers, you get 1 plus. You multiply those numbers, you get 1 plus. You multiply those numbers, you get 0. You add and you get 2. U2 dot U2 is U2 dotted with U2. You get 1 times 1 plus 1 times 1 plus negative 2 times negative 2 is 4 for a total of 6. We're going to use this for all three parts that we're going to do. So now we're going to find the projection of E1 onto P. What does that equal? Well, we know that it's E1 dot U1 over U1 dot U1 times U1 plus E1 dot U2 divided by U2 dot U2 times U2. The only thing we don't know is the following. What is E1 dot U1 and E1 dot U2? Well, E1 is 1, 0, 0, and let us first dot it with U1, which is 1, negative 1, 0, and this is the only entry that's going to give us a non-zero number, because 0 times negative 1 is 0, and 0 times 0 is 0. And what is E1 dot U2? Well, it's E1 dotted with U2, 1, 1, negative 2. And again, it's just going to be the product of the first components. Okay, so the projection is equal to E1 dot U1, which is 1, divided by U1 dot U1, which we computed up here. U1 dot U1 is 2, times U1, which is 1, negative 1, 0, plus E1 dot U2, which is 1, divided by U2 dot U2, which is 6, times vector U2, which is 1, 1, negative 2. I'm going to rewrite the 1/2 in front as 3 over 6. That way we have a common denominator. I'm going to factor that out. So we're basically going to have 3 times 1, negative 1, 0, plus the 1 times 1, 1, negative 2. 1, 6. Well, 3 times those numbers will be 3, negative 3, 0, plus 1 times those numbers will just be those numbers. So we still have the 1/6 in front, and then we add 3 plus 1, negative 3 plus 1, and 0 plus negative 2. Now, I could divide each number inside the big brackets by 2, which means I need to multiply that number by 2 to counter it. Well, that gives us 1/3. Okay, so we found the projection of E1. Now we're going to do the same thing for E2 and E3. E2 is going to be 0, 1, 0. And U1 did not change. It is 1, negative 1, 0. And U2 did not change. It's 1, 1, negative 2. So E2 dot U1 is only going to come from the middle component. It's going to be negative 1. And E2 dot U2 is only going to come from the middle component. 1 times 1. Why? Because 0 times 1 is 0, and 0 times negative 2 is 0. So adding the zeros don't matter. Okay, and remember that U1 dot U1 was 2, and that U2 dot U2 was 6. So the projection of E2 onto P is E2 dot U1 over U1 dot U1 multiplied by U1 plus E2 dot U2 over U2 dot U2 times U2. Well, E1 dot U1, that's negative 1, over U1 dot U1, that's 2, times vector U1, which is 1, negative 1, 0, plus E2 dot U2 is 1, divided by U2 dot U2 is 6, times U2, which is 1, 1, negative 2. Again, we have a 6 on the bottom. So I'm going to leave the negative sign, but I want to write the 1/2 as 3 over 6. Negative 3 over 6. So now I can factor out the 6. We have negative 3 times 1, negative 1, 0, plus 1 times that vector, which is just going to be that vector. So we have 1/6, negative 3, 3, 0. Negative 3, 3, 0. We add 1, 1, negative 2. We get negative 2, 4, negative 2. Ooh, what's in those brackets I can divide by 2. But then I need to multiply that number by 2, which makes it 2/6 or 1/3. Okay, so that's done. We just found the projection of E2 onto the plane, which is that answer. Then we do the same thing for E3. E3 is 0, 0, 1. And U1 is still 1, negative 1, 0. And U2 is 1, 1, negative 2. So E3 dot U1 is just going to be 0. And E3 dot U2 is just going to be negative 2. Why? Because if you multiply these two zeros by 1 and negative 1, you're going to get 0. 0 plus 0 plus 0 is 0. 0 plus 0 plus negative 2 is negative 2. Now, the projection of E3 onto the plane P, this is equal to E3 dot U1 over U1 dot U1 times U1 plus E3 dot U2 over U2 dot U2 times U2. Well, E3 dot U1, that's 0. And U1 dot U1 is not 0, it's 2. So that's 0. And when you multiply each component in vector U by 0, you're just going to get the 0 vector. This is just 0, 0, 0. Plus E3 dot U2, that's negative 2 over U2 dot U2 is 6. And this gets multiplied by U2, which is 1, 1, negative 2. I'm going to reduce that, we're adding, I'm going to reduce it to negative 1/3. Now, since all the other answers had 1/3 factored out, I'm going to just multiply each entry by negative 1. I get negative 1, negative 1, and 2. Okay. Now, they all the projections had 1/3. This being E3, it becomes the last column. The one above, that's the projection of E2. I have the 1/3 in front, but I need negative 1, 2, negative 1. Negative 1, 2, negative 1. And if we go up to the top, we'll find the projection of E1 is this. Again, the negative 1/3 was factored out, times 1, negative 1, negative 1. 1, negative 1, negative 1. But I think there's one thing wrong. Okay, so I have her 6 right here, and I have it here. 3 plus 1 is not 2, it is 4. And when I divide by 2, I should get 2, negative 1, negative 1. And then I multiply, since I divided this by 2, I have to multiply that by 2, which becomes 2 6, which reduces to 1/3. So it's not 1, negative 1, negative 1, but rather it's 2. Now, this here is the answer. Let us just check to make sure we didn't make a mistake. So here is our check. This here is the projection vector. And when I compute the projection of 5, 0, 2, I have the 1/3 times, well, this vector, or that row, times the first column is going to be 10 minus 0 minus 2, which is 8. When I multiply this row by that column, it's negative 5 plus 0, which is still negative 5, minus 2, which is negative 7. And when I multiply this row by the column, I get negative 5 minus 0, which is still negative 5, plus 4. Well, negative 5 plus 4 is negative 1. And this time I will just multiply each component by negative 1/3. So I get 8/3, negative 7/3, negative 1/3. And again, this should be the projection of V, which was 502, on P. Did they call that V? The projection of V onto P should be this. But if you check our work, I think it was part B11, 2B11. That is what we got. And we also got it by multiplying this transformation matrix by vector V, and we got the same answer. Sorry it took so long to get this one done, but here it is correct. We checked it. Thank you. Bye.